Hello everyone, today we are going to explain something we often hear about in our company called NAT. Why do we need NAT in our company? Let's take a look. Suppose this is a gateway device in our company. Generally, we refer to the gateway device as JW, and it is responsible for connecting with the service provider, or for example, our R here represents the service provider. Now, in this process, in the future, when we access the internet, we actually have to go through the service provider. So when our company is handling business with the service provider, what situations generally occur? There are generally two types. One is called PPPoE dial-up internet, and the other is called Internet Dedicated Line. However, regardless of which of these two it is, they will both assign us an IP address. The difference is, if it's PPPoE, it will give us a dynamic address, meaning the address I get each time I go online is different. For example, if I go online today, I might get 1.1.1.1, and tomorrow I might get 1.1, 1.2, which are different each time, and we call this dynamic. Apart from this, corresponding to it is our Internet Dedicated Line. The address it provides us is a static address. In this process, when we go online in the future, are there any other differences besides dynamic and static? Well, of course there are. If it's in a mode like PPPoE, the upload and download speeds will be unequal, but the price is relatively cheaper. As for the dedicated line, its upload and download speeds are consistent. Often when businesses handle operations, they opt for this dedicated line, because in this process, companies are very concerned about upload speeds. Well, why? For instance, when we access a website or a web page in the future, we are actually accessing their server. Their server provides us with certain services. But how can we download from the server if they don't upload? Therefore, they generally care more about upload speeds. In such cases, after we set up this dedicated line and handle this business, they will give me a service order, which will specify details. For example, it will allocate an IP address to me in the future. Now, during this process, the IP address is 100.1.1.1 for us. Besides the IP address, there's also our subnet mask. Now, during this process, if they allocate a subnet mask to us in the future, let's say they assign us 255.2555.2555.252. In addition to this, they will also provide us with a gateway address. Suppose they give us 100.1.1.2 as the gateway address. So what does this prove? First, we need to understand that the address 100.1.1.1 allocated to us in the future is meant to be configured on a device. But which device should I configure it on? Should I assign it to my end users? They only gave me one address, so what if I need to configure it on other devices? So this address, in fact, we need to configure it on the gateway to interface with the service provider. This interface is configured on the J001 interface for future interfacing with the service provider. Suppose the address is 100.1.1.1, then where is the so-called gateway in this context, since in the future we will be accessing any website? Whether we are talking about going on YouTube or accessing some internal websites of various countries, so during this process, we actually need to go online through the service provider. In the future, when the service provider sets up an interface for us, they will also give us an address telling us that if we want to connect to the external network, it's fine. Just use this address, and they will help us access the external network. Alright, now in this context, let's say our service provider can help us access a website with the address 8.8.8.8. I have a unique address configured on the gateway device. So what address should I configure below it? This actually involves our IP address, a concept where our IP addresses are divided into private addresses and public addresses. So what is a public address? For example, 101.1.1 is an address we pay for, and it is unique, meaning only I can use it and others cannot. This is what we call a public address. A private address, on the other hand, is free and can be used repeatedly. However, the repeated use does not mean that within a company, many devices should use the same private address. That's not the case. I might find it in any local area network. Someone might use this private address, whereas a public address means that you are the only person using it globally. So how can we tell if an address is public or private? Actually, This is determined by an international organization called INA. Within ABC, our IP addresses are divided into a range for our private network addresses. If it's Class A, the range is from 10.0.0.0 to 10.2535.535.255, which is our Class A private address. If it's our Class B address, the address range is 172.16.0.0 to 172.131.25.5.255. And for our Class C, during this process, its range is 192.168.0.0 to 192.168 points. 255.255. This is a subnet address for our ABC3 classes. If we are a small company, generally, you will find that our internal addresses often start with 192.168. If it's a medium-sized company, our addresses often start with 172. And if we are a large company, generally, our internal addresses start with 10. So if I'm a small company but I want to use this Class A address, is that possible? Actually, it is possible. We just use this kind of situation in most cases. Now, in this process, we can see that if I get a public address in the future, then for my devices below, I can configure a subnet address for them, such as 192.168. 1.10, well, now, in this process, in the future, we need to configure the devices. And for example, in the PC, we need to set it up, its IP value. 192.168.1.10, and our subnet mask is 255.255.255.0, while our gateway is 192.1168.1.1. So our PC's gateway is somewhat special. Because our PC here generates data, its main responsibility is not to help others transmit. Now, if you configure a gateway address for it in the future, this gateway address, is deployed on the interface of our device, an IP address. In the future, as long as there is something I don't recognize, meaning it's not in my routing table, I will send it to the gateway and let the gateway forward it for me. Suppose in this process, we let the gateway's 000 port act as the gateway address for my PC. Well, in the future, we still need to configure it on the device. For example, now we enter the device internally. First, I need to change the name. For example, in this process, I need to first enter the system view from the user view, then enter our interface to configure the IP timing. Of course, here we first modify its name. Suppose its name is JW. After renaming the W gateway, we then configure the IP value for interface J, 0000, and then we assign it the IP address, 192.168.1.1 as a gateway for my PC below. And here we also need to configure the subnet mask, which we can simply replace with the wildcard length. Besides this, I need to connect to our service provider, so I also need to enter the 001 interface to configure the ANSO IP address, which is 100.1.1.1 here, and the subnet mask I assign is 255.255.255. 2 on 52. If we convert it to a subnet mask length, it is 30 bits. Now here, this is our gateway, and after configuring it, we also need to configure the service provider side. Similarly, I first need to enter our system view, and then change its name. For example, here we will call it service provider. Besides this, we need to assign it an interface. In the future, when I connect to this gateway, I need to assign an IP address to the G000 interface, which corresponds to the service provider on our previous business form. The gateway address for our PC within the enterprise is 100, 1.2, and then write a subnet mask of 30 bits here. Besides this, in the future, if I want to simulate, I have a network segment at the back, and we can directly simulate the back through this device using a loopback interface. I have such a network segment, and interface 0 is a virtual interface. Why? Now, in this process, we can set the IP address to 8.8. 8.8 with a 32-bit mask to simulate having such a network segment at the back. Alright, now let's take a look here. If my gateway is set, can I directly reach the service provider? Here we can use the ping command. If I can access 100.1.1.2, then it proves that my configuration is correct. Now, during this process, it is possible because we are directly connected. Since I can access the service provider with my gateway, well, can I access 8.8.8.8? Can I? Let's take a look now. Ping 8.8.8.8. At this point, it's not possible. Why is it not possible during this process? Because when the device forwards, it needs to check the routing table. So how do we check the routing table here? We need to use a command called display IP routing table. Now, in this process, do we have our destination 8.8.8.8? No, it doesn't. If it's not there, it can't forward, In the future, when we access anywhere, it's actually through the service provider. So here, we can write a special static route, also called a default route, which means that no matter where I go in the future, I will send it to the service provider. Do I know what website I might visit in the future? I don't know, so we use 0.0.0.0 as a substitute. Do I know what the other party's gateway is? I don't know either, so here we also use 0.0.0.0 as a substitute. Besides this, there's our next hop, which means the next step I should take. Now here we use 100.1.1.2, right, as the next hop here. I only know that in the future if I want to send it to the telecom. During this process, I wrote down the interface address of the other party and the person directly connected to me, which is 100.1.1.2. Now, can I access my 8.8.8.8 here? Isn't there no problem now? Okay, let's take a look at my PC1 and see if I can access my own gateway. Hi, let's check it out first. Ping 192.168.1.1. Now, during this process, it's possible if I can access my own gateway, and my gateway can use the service provider to access 8.8.8.8 here. Then can I directly access this 8.8.8.8? How can I take a look? Now, if I access this 8.8.8.8 here, can I receive messages? It seems completely impossible now. So why doesn't it work? First, we need to consider something. Here, we are using 192.18.1.110. What is this? This is a private network address. What is a private network address? It means that any internal network, any local area network, might have a device called 192.18.1.10. For example, when I'm online, everyone else is also online, and each of us is browsing YouTube. However, everyone wants to see different content. For instance, some people like listening to singing. Some students prefer listening to internet-related topics, and some students enjoy watching others dance. There are also students who like watching food vlogs. Now, in this scenario, everyone is accessing the YouTube server, but each person is requesting different things. For example, I want to listen to singing, while other students want to watch dancing. However, for the server, it appears that all requests are coming from 192.18.1.10. In this situation, it becomes impossible to distinguish who corresponds to whom. Therefore, in this context, we actually cannot use private network addresses to access public network addresses directly. We need to perform a conversion. How do we convert? This is where NAT, the Network Address Translation Protocol, comes into play. It means that internally you use private network addresses, but when going out, I will convert it to a unique address for you, converting it to a public network address. NAT has many types, and we say that any private network might have these private network addresses. So we need to perform a conversion. In enterprises, the most commonly used type is actually easy IP. What does this mean? It means that any IP address, when going out to access the internet, will be converted to an exit address. For example, if my PC1 here wants to access the internet, I will convert it to the interface address of my J001. So how do we do this here? Today, we will just demonstrate easy IP for everyone. If you are interested in other types of NAT, such as static NAT, dynamic NAT, NAPT, NAT server, there are actually many types, a total of 5 kinds. So today, we are focusing on just one type. If you are interested, you can send me a private message, and we can also engage in technical discussions below our video. Now let's take a look if during this process, my JW. I need to configure this NAT. And first, we need to decide on one thing, which is who will perform the conversion when going out. Because if it's a bank, some internal teller machines might not be able to access the external network. The answer is, generally, companies don't have specific rules, but here, we need to write an ACL, an access control list, to specify who will perform the conversion when going out and who will not. Typically, we use BASIC. ACL, for example, ACL 2000, this 2000 is its identifier cell. Then we write the corresponding rule. Permit source any. So what about small businesses in the future? Actually, their requirements aren't that many. Anyone can go online. So here I've set a rule that allows anyone to go out, and I will perform a conversion for them. Now, I've just written this rule, but I haven't applied it, meaning no one is doing this task yet. In the future, we need to call NAT under the interface. This is our Enterprise Gateway Exit interface, and all traffic needs to go out through this interface to connect with the service provider. Therefore, we will choose to perform NAT on this interface J00 So how do we do it? It's called NAT Output 2000, which means during this process, when I go out, I perform a conversion for you. How is it converted? For example, right now, we haven't pressed enter here, we haven't activated it, so when I normally go to access this J01, let's take a look by capturing packets. Packet capturing can help everyone better understand some of the data transmission situations in the network. Now, during this process, suppose I use this PC1 to access the service provider. I go to ping 8.8.8.8. Now, during this process, the data will reach our gateway, and our gateway will send it to the service provider based on its routing table. However, in this case, the service provider will not reply to us because the source address I send, my own original IP, is 192.0.18.12.10, which I want to send to the other party. The other party's address is 8.8.8.8. But when they want to send a packet back to me in the future, they have no way to do so. First, this is a subnet address, and every internal local area network has a subnet address. Secondly, their routing table does not have it. However, if we now in this context, after configuring NAT, now let's take another look. When PC1 accesses 8.8.8.8 again, I will provide an indication here for everyone. Below are some of our latest packets. Now, when I access it again, what does our original address become? Our original address becomes this exit address, which has changed to 100.1.1.1, and it is sent to the service provider. Now, the service provider knows from this that, you are from the 100.1.1.0 subnet. This is directly connected to me, and I recognize it. In the future, I will reply to you through this 000 interface. What about the gateway device? Since it also has an internal NAT mapping table, it can correctly respond to our PC, allowing our users to communicate. In our enterprise, if in the future everyone needs to access the external network. In fact, NAT is used to perform this network address translation to the public network to help devices achieve communication. This is our NAT technology. If anyone wants to learn Huawei certification technology or obtain Huawei certification question banks, you can send me a private message, and I can also leave more comments below the video for technical exchanges. This is our NA for today.